Let us discuss under the concept of oscillations and simple harmonic motion, the concept of waves and wave motion as such. Generally, this topic wave motion, when we consider under this chapter, this is the study of sound what we are having. Under wave motion, we are studying much about sound and its general characteristics and other applications. What is a sound in general? We used to consider this one as a form of energy. Now, the next concept over here is anything, of course, whatever we consider in physics, that we consider it like a form of energy only. Electricity is energy, magnetic energy we call it. Likewise, sound also is a form of energy we are going to take up. And what kind of energy it is and how can we produce this sound? For that one, we have a basic concept like this. Every vibrating body that produces sound. So, what one has to understand here is, to produce sound, the body should vibrate. Whenever the body is producing sound, it is understood that it is vibrating. We are talking like this means it is understood our vocal cord is vibrating. That only is producing the sound over here. Now, the question is, when you make every body vibrating, which is in vibratory condition, produce sound like a statement. When I take this body and make it vibrated in air, we should get sound. But we are unable to hear any sound from this example. What is the reason? For that, we all should understand there is an audible range. What is this audible range for us? It is between 20 Hz and 20,000 Hz. One should understand this audible frequency range, whatever we are talking about, is 20 Hz. What is 1 Hz in general? 1 oscillation per second or 1 vibration per second. That is what is called a Hz. So, 20 Hz to 20 kilohertz, 20,000 Hz. What is the meaning of it? If a body vibrates 20 times a second or up to 20,000 times a second, the body whatever is just producing sound in vibrating, between these two values, all those sounds can be heard. That is what we call it as audible range of frequencies. So, when you talk about 20, less than 20 Hz, we call them as infrasonics. Infrasonics are those waves which will have frequency less than 20 Hz. More than 20,000 Hz, when we talk about them, they are called ultrasonics. In fact, we all are aware of these things like bats, dogs and other animals, like they can produce ultrasonic sounds. That is the concept what we need to know. So, infrasonics and ultrasonics cannot be heard by us. Only in between these two frequencies, whatever the sounds they are being produced by different objects or different sources of sound, we can hear very clearly. That is the point. Now, the next question is, what is the nature of this sound energy what we are talking about? Nature in the sense, one should understand sound has wave nature. It is not in the form of particles. It is in the form of waves. Now, wave nature is okay, but there are different types of waves they are existing, which in fact we all know as well. Which wave this sound is? First and foremost, will it require medium to travel or not? That is what we have to look into. For example, light waves when we consider, they do not require material medium to travel. In other words, we can say light can even travel through vacuum. And the speed of light in vacuum only, we used to take it as 3 into 10 to the power 8 meter per second. Likewise, when we consider sound waves, will they require medium to travel or not? In fact, sound requires medium. Therefore, we should say that these waves are non-electromagnetic by nature. So, they are non-electromagnetic waves, and of course, they do possess energy. Therefore, we can even call them as mechanical waves. They are non-electromagnetic mechanical waves. But the next concept over here is non-electromagnetic. The moment we write, they just require medium to travel. Without a material medium, sound cannot travel. So, what we should understand out of this one once again, what would be the speed of sound in vacuum? What would be the speed of sound in vacuum? Speed of sound in vacuum is 0. That means it does not travel through vacuum. It needs a material medium to travel. That is the concept one has to understand from that. Now, the next concept over here is no doubt non-electromagnetic we have declared. The waves which are of course the sound waves, so called, what we are talking about, they are non-electromagnetic, fine. But out of non-electromagnetic also, what exactly is its nature? Because there are different types of waves which we have discussed in lower classes. One longitudinal wave we all know, one transverse wave we know. Which wave this sound wave is? For that, for knowing about that one, first and foremost, we need to know what are longitudinal waves and what are transverse waves. When we know their basic nature and basic properties, then automatically one can conclude what kind of waves are sound waves as such. So, let us now take up first of all what are longitudinal waves and what are transverse waves, what are the major differences between these two, and how to identify the nature of a wave, whether it is longitudinal or transverse for that matter.